All right, good morning. Welcome back to trigonometry. So here we have the graph y is equal to 2 sine of 3x minus pi over 4, all minus 1. Uh, on this thing, there's going to be further instructions where it's going to say graph one cycle. Okay, label at least 5 points. Okay, well, five or more points, it's going to say. Okay, 5 or more points. And let's go ahead and get started with this thing. So on this problem, notice that there isn't a reflection or anything like that. So I could graph a basic sine wave and think about that. And I'm going to go ahead and draw my axes in here. And normally, like we have an X and a Y here. Now, there's a midline at -1. Okay, so I'm just going to kind of dot in my midline here, assuming it dots in for me. Okay, and this is y is equal to -1. And I care about that because this is where the graph is going to dance around this midline for me. Okay, we have a amplitude of 2, so we're going to go up from 1, 2. So it's going to be up here at 1, and we're going to go down 1, 2, down to -3 here. All right, so from here, I'm going to need a few points. Normally, I would like to start from 0 to 2 pi and do it that way, but we have a period shift, we have a phase shift, so that's not really going to work. So what I'd like to do is, if this was just the parent function, we would graph for x is equal to 0, x is equal to pi over 2, x is equal to pi, x is equal to 3 pi over 2, and finally x is equal to 2 pi. That's what I would like to graph. That's not what we have. So what I'd like to do is figure out what does x have to be so that my argument is going to be x is equal to, the argument is going to be 0. So I want this thing in the middle to be 0. Well, how do I make that happen? Well, let's set 3x minus pi over 4 equal to 0 and see what x has to be. 3x minus pi over 4, set it equal to 0, and we'll go ahead and solve this. So we can say this is 3x is equal to pi over 4. We'll go ahead and divide both sides by 3. So we have x is equal to pi over 12. All right. The next one up. I usually skip it and I usually skip this one and I jump to the pi first just because it's a little bit easier to solve. But we'll come back and infill this thing here. So we have 3x minus pi over 4 is equal to pi. So the idea is, what does x have to be so that this thing in the middle here turns into a pi? Because I can figure out the sine of pi, that's 0. And if you can't, I mean, you should be able to, but at the same time, I never took your calculator away. You could always double check it. Okay. Make sure you're in radians, but you can always double check those things. All right. And then we're just going to go ahead and solve this. So I have 3x equals to pi plus pi over 4. Now, we got a fraction. I can't just go around and leave this as a pi plus pi over 4. We have to get this together. So what I'm going to do is I'm going to turn pi into 4 pi over 4, right? $, 4/4. And we're going to go ahead and add that together. So we have 3x equals, you've got 1 pi over 4, or 4 pi over 4 plus 1 pi over 4. That's going to equal 5 pi over 4. Go ahead and divide both sides by 3, and we have x is equal to 5 pi over 12. Right? And that, if I go ahead and I plug x equals to 5 pi over 12, I plug it back into this x here, this whole thing together, this argument, will turn into a pi, and I know what the sine of pi is. It's 0. All right? So that's what we're trying to do with that. All right. Um, let's go ahead and see what we've got for pi over 2. Okay, so I've got 3x minus pi over 4 is equal to pi over 2. That's one of the other numbers I'd like. So my first move is to move the pi over 4 to the other side. So we're going to say 3x equals pi over 2 plus pi over 4. Well, again, we got to get common denominators here. So I'm going to go ahead and change this to a 2 pi or I'm sorry, a 2 over 2 times pi over 2. That's going to give me 2 pi over 4 plus 1 pi over 4. So we're going to have 3x equals 2 plus 1 is 3 pi over 4. And I will go ahead and divide. And you might think, like, I can cancel the 3's. And like, you absolutely can. But I'm looking for a pattern and I don't want to divide and remove information from my pattern. So this turns into a 3 pi x equals a 3 pi over 12. Okay, so here I've gone 1 pi over 12 to 3 pi over 12 to 5 pi over 12. Uh, I'm I'm sensing a pattern here. Okay, so technically, I don't think I have to finish out doing these linear equations to say I think it's going to be 7 pi over 12, right? 1, 3, 5, 7, 9 pi over 12. So we can go ahead and kind of take a look at what that's going to look like. These are my guesses. All right, I'm going to go ahead and verify them. You don't have to do this, but I'm making a video here, put it on YouTube. People will be able to point and laugh at me. I want to double check it. Okay. Besides, not everybody is able to like see these patterns. So if you didn't see the pattern, sometimes they are a little tricky. Let's just demonstrate how to do it. So we have 3x minus pi over 4 is equal to 3 pi over 2. Let's go ahead and add the pi over 4 to both sides. So we have the 3x equals 3 pi over 2 plus pi over 4. And we'll go ahead and figure out what that's going to happen with there. So again, we need common denominators. So I'm going to multiply it by 1. I'm going to multiply it by 2 over 2. 2 times 3 is 6. 2 times 2 is 4. So we have 6 pi over 4 plus 1 pi over 4. That is 3x is equal to 6 plus 1, 7 pi over 4. Last thing we're going to do, divide both sides by 3, and we get x is equal to 7 pi over 12. Oh, look at that. They did match. Okay, lucky me. Lucky. And then we'll just finish this off. So we have 3x minus pi over 4 is equal to 2 pi, right? So what does x have to be so that when I plug in my x, this whole business here will turn into a 2 pi. I know the sign of 2 pi. It's 0. So that's a number I would like to try. I would like to graph. So we're going to say this is 3x equals 2 pi plus pi over 4. And again, we can't leave this. We have fractions with different denominators. We're going to change that. So I'm going to take this is 4 over 4 because everybody's in fourths. We get 8 pi over 4 plus 1 pi over 4. So we have 3x equals 8 plus 1 is 9 pi over 4. And then my last step here is divide both sides by 3, and I have x is equal to 9 pi over 12. And hey, would you look at that? They matched again. I did guess a good pattern. Okay, so now we are ready to start graphing. There's a couple more things I might want to do. What if they ask you for the period or a wavelength? We're going to say, well, where does it end? Was 9 pi over 12. Where did it begin? That was 1 pi over 12, right? So we can subtract them. This was the end minus the beginning. 9 minus 1 is going to be 8 pi over 12. And at that point, now I do want to reduce because I want to compare it to something else. 8 is really a fancy way to write 2 times 4. Okay. 12 is a fancy way to write 3 times 4. So we can cancel some stuff. And I get 2 pi over 3 in order to do this. All right. Now, to remember the period formula that they tell you in the book, that the period is equal to 2 pi over b. And then we have to go look up, what the heck is b? Okay, so we're going to look all the way back up here. B is 3. Okay, so my period is 2 pi. Oh, look at that. They also match. So that's good. As far as my phase shift goes, now remember, phase shift, we can't just write it, we can't just take whatever the plus is. We have to adjust it by the horizontal squishing or spreading out that is in here, okay? So this 3x minus 4, okay, I can't write it as 3x minus 4, minus pi over 4 rather. What I've got to do is I've got to factor this 3 out of this. So that equals 3 times x minus. Now, if I factor out a 3, how do I pull a 3 out of this? I got to make it come back. So I'm going to say this is going to be pi over 12. When I put the 3 back in, do I get the same thing over here? Yes, that's the point. So my phase shift is pi over 12 to the right. All right. I would have liked to start at 0 because a parent function for sine starts at 0. Where did I actually end up starting? Oh, look at that. We started at pi over 12. Go figure. So this, there's some extra information that doesn't always come out of the graph, but you have all the information to get that extra information, right? The amplitude, we can do that by inspection. That's 2. There's no reflection. So here I'm going to say, here is my pi over 4. Okay. Or pi over 12 rather. That's my first number. Let's change that to a pi over 12 and put it where it's supposed to be. So this was, we'll go here. We'll say this is pi over 12. We'll write right here, pi over 12. And what's my last number? My last number was, I think, 9 pi over 12. It sure was 9 pi over 12. So here we are with 9 pi over 12. And then I've got to get halfway between here. It's about right there. What was the halfway number? It was 5 pi over 12. If you say lose your papers and you're like, I don't remember, could I average 1 pi over 12 plus 9 pi over 12 and then divide this by 2 or multiply by half? Like, yeah, we could do that. That would be 10 pi over 12 times 1 over 2, and then we would still get 5 pi over 12. So you can just go ahead and average them. It'll work out to be the same. It'll be fine. So we can go ahead and get this one. This should be pi over 2, so this is 3 pi over 12. Okay, and then we have 1, 3, 5. I'm going to go ahead and say this was 7 pi over 12. And then we've got some points that we can go ahead and graph here. Now remember, my center line is actually y equals -1. So I'm going to go ahead and put a point in here. Sine tends to go up. So pi over 2, sine of pi over 2 is 1. We go back down to 5 pi over 12. If I plug in that, we're going to get a 0 here. Okay, so oh no, we're not. We're going to go get, yes, we are. We're going to go down here. So 7 pi over 12, that's going to be way down here at -3 because it's 3 pi over 2. It's going to give us a -3. And then we are back up to this point right here. So now I've just got to connect my dots here. Okay. All right. And again, if I wanted to keep going, we could. If I had a problem where it's a complete more than one cycle, I could say, it's 1, 3, 5, 7, 9. I think there's a pattern that's pretty much established. I could say dot, 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 with the expectation that nobody is going to like decide that they're going to come up with different numbers. Like, I think it's 14. No, it's got to be an odd number. It's 1, 3, 5, 7, 9, 11, 13, 15, 19, etc. And just count through it. But that would be our graph of how to graph this thing. And it even gives us if I asked extra questions like what's the period or what's the phase shift, like your book frequently does, um, you'd also be able to answer those questions. So with that, I'm going to say thank you very much for watching, and I will see you on the next video. Thanks.